Alright, so let's talk about characteristics of some polynomials, things that we know about these functions just based off of the graph. And I'm going to start over here. And we're going to name this function. Most of you are pretty good at that. So we look at the highest exponent, known as the degree of this function, and it's the fourth power, which means it is a quartic function. And there are 1, 2, 3 terms, so that makes it a trinomial. So take a look at this quartic trinomial. You'll see that both of the ends are pointing down, and then there's a little kind of a hump in here in the middle. And a big difference between this and a quadratic function. A quadratic function, if it was negative x squared plus 4 or something, it would look like this. And so x to the fourth is very similar. We have a quadratic term in the middle, which makes it dip down since it's a positive quadratic term. Okay, so let's talk about domain and range for this function. I think most people are going to say all reals. And then for the range, you see that there is no minimum value, there is no lowest value, but what is the highest value? This function never gets above this point over here. And so we've got a little work to do at this point. We have to go to the calculator and we have to know what that point is. Those are maximum points. And a maximum point is going to show up on our calculator, and it's going to show up in the range. So give me just a second and I'll enter that into the calculator. And now this function is in the calculator. And so I'm going to hit zoom and 6 because my window was kind of funky. And you see, look, it goes up too far, which makes sense because the graph on here goes up to, it needs to go up to at least 15 to get these two maximums in it. So I'm going to go to my window. You'll select window on the calculator. Let me move this over a little bit. Select window, and then we need to change these y values. My graph doesn't go up high enough. Up is the y direction, and I need to change the maximum. I'll change it to 20 just to make sure I can see everything I need to see. And now it looks very similar. Okay, so I need to know these maximum points. And maximums go under extrema. So you're going to be killing two birds with one stone here. Second trace, I want to know a maximum, which is number 4. So you use the left arrow key to go over towards that first maximum, which is about right there. We need to get on the left side of it and hit enter. Then we need to hit the right arrow key to get to the right side of it and hit enter again, and one last time. And you see the maximum, negative 1.414214. We'll round it to negative 1.4, comma 14. So extrema, negative 1.4, comma 14. And that is a maximum. And I'm going to have to make sure that I don't know if it's local or global yet. So I just found this point over here. If this point gets above that point if this point is higher than this one, then that makes this a local maximum. If these two are the same height, then they're both global maximums. No, there are no other points that get above that point. So let's find that other one over there. A maximum again. Use the cursor, bring it over to this point right here as the maximum. Make sure you're a little bit to the left of it and hit enter. And go to the right side of it and hit enter twice. 1.414, 14. So they are the same height. And 1.4, 14, global maxima, or maximums. Alright, while I'm here, I'm going to get the minimum. But we can now finish the range off. Negative infinity, there is no lowest y value, but we found the highest value to be 14. The function never gets above that point. There is also a minimum point right here, and that one is a local minimum, or you could say relative, just like you could call the maximums absolute. And let's find out what that point is. Second, trace. This time we want a minimum. Go to the left of it, enter, go to the right side of it, enter twice. Okay, you see where it says -1 e -6? That means times 10 to the -6. So it's basically 0. 0, 10. And that's just a weird thing that comes up sometimes because it's trying to get as close to that point as it can, and it's just not registering quite that it's 0. So this would be negative .000001, which is just 0. And notice that's the y-intercept. Looks like it, doesn't it? If you look at the function, the constant term is 10, which means we have a y-intercept at 0, 10, and that happens to also be the local minimum, 0, 10. And I'll put it right here, 0, 10. Just doing all kinds of work with these things. Okay, so what else do we need to do? In behavior. How do the ins behave? We're looking at these two things. They point in multiple directions. This one is pointing left and down. It's much more down than left, but it is still moving to the left. And so on the left side, the x values are going in the negative direction forever. The y values are going also down the negative direction forever. And what's happening on the right side? On the right side, we see that the x values are going in the positive direction, y values are going in the negative direction forever. X approaches infinity, y approaches negative infinity. All right. Because we've done the extrema, we can do intervals increasing and decreasing. So let's do that. You can draw some arrows on your graph. So starts out by going up. That would be increasing. Then it decreases for a little bit. Then it increases for a little bit. And then it decreases again. Up, down, up, down. That's the pattern. Okay, so we increase to maximum points, and then they start to decrease. What interval is that? From negative infinity all the way until when, not how high, but when. When does it start to decrease? At negative 1.4. Okay. And you'll notice that with intervals, you bounce between the increasing and decreasing. So now we're going to come down here. At negative 1.4, which is this point up here, starts to decrease until it gets to this local minimum, which occurs at 0. And then, boom, going to bounce back up to increasing. From 0 until 1.4, the function will increase again. That's your next maximum. Okay. And then at 1.4, it will start decreasing again, and it will decrease forever. That is in the positive infinity direction for the x values. Yes, the y values go down to negative infinity. Don't care. Decreases forever. That tells us it's going to go down towards negative infinity. All right, one thing to notice, among many things, but one thing to notice right here, negative infinity and infinity, those are like the bookends because that's what the domain does. It goes all real numbers. And then every single other number here is an x value of one of my extreme values, either my minimums or the maximums. All those points are x values, and they're either infinite because they come from the domain, or they are the x values, the locations of your maximums and minimums. Okay, and the last thing for this video is we need to find these two zeros. All right, how many zeros does this function have? It is quartic. That means it's got 4 zeros. Fundamental theorem of algebra says so. 2 of them are real. We can see them, one here and one here. 2 of them are non-real, and we're going to worry about figuring those out later. So for now, we've got, we'll say 2 non-real, and then there's 1, and there's another one. Where are they? So second trace, we want zeros this time. Go all the way over to the left. Okay. I'm looking for this point right about a little bit above there. I'm looking for this point up here. Make sure to get to the left side of it by hitting the left arrow key and hit enter. Now it says right bound, so hit the right arrow key until you pass this 0 point. Once you get past it, you hit enter again, enter a final time, negative 2.40. And I'm going to get the last one. I have a feeling it's positive 2.4. Oh, you hit the old arrow key. Trace. Get over here. Okay. Make sure you're on the left side of that 0. Hit enter. Then you get on the right side of that 0 and hit enter. Really important. It doesn't matter how far to the left as long as you don't go way over here past this other 0. Okay, you want it to focus on this 0 on the right. So as long as that cursor left bound is somewhere in this area to the left, as long as right bound is over here, you'll get this point, 2.4, comma 0. 2.40. Okay, so there's number 15. Is that number 15? Sure hope so, yeah. And we'll do another video that will take care of number 16.